Good evening, students, and welcome to chemistry classes. Correct? And yes, you all know, today we are supposed to discuss the papers. The discussion paper which has been posted already in what WhatsApp group. Right? So today we are having alkanes. The chapter is hydrocarbon, and for this week we are having only alkanes. So we have posted those 75 questions related to alkanes only, and those things will be discussed over here. So let's see how many questions we can discuss in this session. So let us start without wasting any time. I hope all of you are having the paper, and I hope you have opened it. Let us go through the one by one. So the first one, which represents an alkane? The first one itself is what? Based on the general equation of what alkane. Right? So which represents an alkane? Option number 1 is C5H8. Option number 2 is C8H6. Option number 3 is C9H10. Option number D. Option D is C7H16. So which among these follows that rule? The equation, general equation for alkane is what? CnH2n+2. Correct? So option number D, which is C7H16. C7H16 follows this equation. Correct? So it is C7H16 is an example of what? Alkane. So option D represents an alkane. That is why for first question, option D is the correct answer. Option D. Clear? Similarly, let us go for the next one. Next one is based on the boiling points. Correct? The question is like the decreasing order of boiling points is. The decreasing order of boiling points is. So they have given 3 compounds. All of them contain what? 5 carbons in them. They all contain what? 5 carbons. So n-pentane, isopentane, and neopentane. Those all are n-pentane, normal pentane. Correct? And they have given isopentane along with that. Isopentane is nothing but this is my isopentane. Correct? Similarly, we got neopentane. This is my neopentane. So we are supposed to arrange these things in the increasing or in the decreasing order of what? Boiling points. So they have given 4 different types of orders. We are supposed to find out which is the correct among those. So it has 5 carbons, it has 5 carbons, it has 5 carbons. There are no branches over here. Here there is a branch, here also there is a branch. Okay? So we know that as branching increases, surface area of the molecule goes on decreases. Okay? Surface area. And that is why the van der Waals force also decreases. That is why as branching increases, boiling point goes on decreases. So obviously among this, my n-pentane should have higher boiling point. N-pentane should have what? Higher boiling point, and then followed by what? My isopentane. This is my isopentane. After n-pentane, I'm having isopentane, and at last I'm having what? Neopentane. Clear? So we know that as branching increases, surface area decreases. Surface area decreases, stability obviously it is going to decrease. So that is why first is my n-pentane, normal pentane, and then isopentane, and then followed by what? Neopentane. So among these 4 options, which is the correct one? That's in the first itself, A, option E, A, we are having n-pentane greater than isopentane, which is greater than neopentane. So option number A is the correct answer for second one. For second one, option A. Please do remember option A for what? Second one. Clear? So let us go for the third one. To prepare, you read the question. To prepare a pure sample of n-hexane. To prepare a pure sample of what? N-hexane. N-hexane means how many carbons are there? So there are normal hexane in the sense there are 6 carbons. To prepare a pure sample of n-hexane using a sodium metal. To prepare means on product side I'm having n-hexane. N-hexane in the sense 2, 3, 4, 5, 6. Correct? No? CH3, CH2, 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 CH3. This is my n-hexane, right? 1, 2, 3, 4, 5, 6. I'm having n-hexane. To prepare this n-hexane, they said pure sample of n-hexane using what? Sodium metal. Using what? Sodium metal. Please to remember, my reactant, one of the reactant is what? Sodium metal. Sodium metal as one reactant. The other reactant will be. So just by observing, they have given sodium, they have not given this product, I mean reactant. They have given only one reactant. I am supposed to find out which reactant is this. They have given 4 options. Among those, which matches? Let us see. Option number 1, N-propyl bromide. Option A. Option A is what? N-propyl bromide. Yes, propyl bromide is nothing but CH3, CH2, CH2, Br. So this is option number A, propyl bromide. By using propyl bromide in presence of sodium metal, is it possible to prepare n-hexane? Yes, obviously. So this is nothing but my Wurtz reaction. Correct? No? This is nothing but my Wurtz reaction. But I am supposed to take 2 moles of n-propyl bromide and 2 moles of sodium in presence of what? Dry ether. I am going to get n-hexane. So that is why for question number 3, to prepare a pure sample of n-hexane using sodium metal as one reactant, the other reactant will be n-propyl bromide. So option number A. Option A. For third one, for third, option A is the correct answer. Okay? So let us go for the next one, fourth one. Fourth one, in the preparation of Grignard reagent, they said. Fourth one, what? In the preparation of what? Grignard reagent. What do you mean by Grignard reagent? Grignard reagent is organometallic compound, very reactive in fact. Grignard reagent. Grignard reagent, the general formula of Grignard reagent is what? RMgX. I'm talking about what? Grignard reagent. So the general formula of Grignard reagent is RMgX. It's an organometallic compound. Organometallic compound, RMgX. So in general, it is called as alkyl, and I'm having a magnesium, and I'm having a halogen. So alkyl magnesium halide. Alkyl magnesium halide. Alkyl magnesium halide is the name, general name for what? Grignard reagent. Okay? So let us talk. Let us see what's the question. The question is based on what? Grignard reagent. So in the preparation of Grignard reagent from haloalkane. From haloalkane. What do you mean by haloalkane? Halogen plus alkane. Halogen plus alkane is called as haloalkane. Correct? See, in the preparation of Grignard reagent from what? Haloalkane, the metal. In the preparation of Grignard reagent from haloalkane, the metal, which metal is used to prepare Grignard reagent? If I'm having alkyl halide, then obviously which one? Magnesium. Because Grignard reagent is organomagnesium compound or organometallic compound, organomagnesium. So we need magnesium. So there will be magnesium in what? Grignard reagent. Please do remember this is very, very important, and it is more reactive compound. We need this. We should remember this. You should remember this. We need this one in second year too. Almost in all the organic chapters, we need this Grignard reagent. So Grignard reagent, I'm having magnesium in it. So that is why for fourth, in the preparation of Grignard reagent from alkane, the metal is magnesium. Option number 8. Option 8. For fourth, option A is correct. So Rx plus Mg. Rx plus Mg will give you what? RMgX in presence of ether. In presence of dry ether, you can say. Clear? So this is my question number 4. Fourth, option number A. Option A is the correct answer. Let us go for the fifth one then. Let's see the fifth question. Fifth question. Sodium acetate can be converted to ethane. Sodium acetate can be converted to what? Ethane. By what? They have given 4 options. Which one is to be converted? Sodium acetate. Sodium acetate is nothing but my CH3COO-Na. Sodium salt of carboxylic acid. Sodium salt of acetic acid, you can say. Correct? So sodium acetate can be converted to what? Can be converted to what? Ethane, they said. Ethane means what? CH3. So I have to convert this sodium salt of carboxylic acid into alkane. Correct? No? So that which is the suitable condition they're asking. In first one, heating with lithium aluminum hydride, LiAlH4. LiAlH4 is nothing but lithium aluminum hydride. Lithium aluminum hydride is a reducing agent. Okay, so by using that we can't convert. We can't convert this into this one. Let us go for next. Electrolysis. Electrolyzing its aqueous solution. By electrolyzing its aqueous solution. By electrolyzing its aqueous solution. Nothing but electrolyzing. Electrolysis by aqueous solution means in presence of what? Water. In presence of water. Aqueous solution H2O in presence of what? Water. If you are doing so, I'm going to get CO2 plus NaOH plus H2. NaOH plus H2. Correct? So I hope you remember this reaction. We might have thought this one in while preparation of what? Alkanes. You might be knowing coal-based electrolysis. This is nothing but my coal-based electrolysis. So please do remember in coal-based electrolysis, sodium salts or potassium salts of carboxylic acids are converted into what? Alkanes. So sodium acetate is converted into what? Ethane by electrolysis of its aqueous solution. So that is why option number 2, option number B. Option B is the correct answer for what? Fifth one. Correct? On balancing, if you are going to balance this reaction, I need to take 2 moles of sodium acetate, react with 2 moles of water, so as to give you what? 2 moles of carbon dioxide and 2 moles of sodium hydroxide plus 1 mole of hydrogen gas. Correct? So this is my question number 5. So for 5, answer is what? B. Option B is the correct answer. Clear? So let us go for the next question then. Let us go for the 6th one. 6. See, in the reaction of, they have given reactants over there. CS3Br means methyl bromide plus 2 moles of sodium. See, CH3Br they have given plus 2 moles of sodium. Again, CS3Br. Again, what? CS3Br. And I'm going to get a product. Called. This is called, they said. Which reaction? They are asking the name of the reaction. Just by observing these reactants, we can identify the product. Right? So this is nothing but my what? These two bromines will go along with what? Sodium. So as to give you 2 moles of sodium bromide, and these 2 carbons will combine so as to give you what? Ethane in presence of dry ether. This is nothing but which reaction? Yes, obviously what? Wurtz reaction. So that is why for 6th one, the correct option is what? A. For 6th one, option number A is correct. Wurtz reaction. It is an example of what? Wurtz reaction. Clear? So this is my question number 6. Clear? So let us go for question number 7. My next question. Let us go for question number 7. 7th one. What is 7th one? What they have given? Let us see. In 7th one. Iodoethane reacts with sodium in presence of dry ether. Question number 7 is again based on Wurtz reaction. Again, it is based on a Wurtz reaction. Iodoethane reacts with sodium in presence of dry ether. Iodoethane, how many carbons are there? 2. So iodoethane they said. So it will be C2H5 Iodoethane will react in presence of what? Sodium. With sodium in presence of what? Dry ether. Obviously 2 moles. It is understood. Correct? So if these 2 react, so what you are going to get, you tell me? C2H5. 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 C2H5 is nothing but what? Butane. Butane plus 2 moles of sodium iodide. 2 moles of what? Sodium iodide. So I am going to get butane. Right? It is C2H5. It is also butane. So C2H5 combines. Right? So I am going to get what? Butane. Option number D. So for 7th one, the correct option is what? D. D is the correct option for what? 7th. Let us go for the next question then. The next one is what? My 8th one. Let us go through the 8th question. Which of the following is oxidized by KMnO4? For 8.1. I'm talking about 8.1. Which of the following is oxidized by KMnO4? Option A is methane, option B is pentane, option C is isopentane, option D is neopentane. See, option 1 is methane, simple. Option 2 is pentane, 1, 2, 3, 4, 5. They said pentane, okay, a normal pentane. Option C is isobutane. Isobutane in the sense, this is my isobutane, correct now? This is my isobutane. Methane, this is option A, this is option B, this is option C. Isopentane, and the last one is what? Neopentane. They said neopentane means water. There will be 5 carbons. We know this. It is neopentane. So the question is, which of the following is oxidized? Which among these can be oxidized by KMnO4? Please do remember, KMnO4 can't oxidize. Generally, alkanes and aromatic hydrocarbons will not undergo oxidation with what? KMnO4. They won't undergo oxidation with what? KMnO4. Alkanes are less reactive compared to alkenes and alkanes. You might be knowing, correct? Alkanes are non-polar, correct? Their reactivity is less. Whereas alkenes and alkanes are more reactive compared to what? Alkanes, correct? So one thing you remember, generally alkanes won't undergo oxidation by using KMnO4. Please do remember, they will undergo oxidation, but they will be it's difficult for them to undergo oxidation by using KMnO4, I'm saying. They will undergo oxidation, but by using KMnO4, generally they won't. If alkane has to undergo oxidation with KMnO4, then there should be a presence of what? Tertiary hydrogen. There should be a presence of what? Tertiary hydrogen. If suppose there is a tertiary hydrogen, then that particular alkane will undergo oxidation with what? KMnO4. Then is there any tertiary hydrogen in this case? 1, 2, 3, 4? Yes. In case of isobutane, I'm having this tertiary hydrogen. This is my tertiary hydrogen. Correct? Because this hydrogen is attached to this carbon, and this carbon is further attached to how many carbons? 3 carbons. So this will be my tertiary hydrogen. If suppose there is a tertiary hydrogen, then that particular alkane will undergo oxidation in presence of what? KMnO4. Please do remember. So option number C is the correct answer for question number 8. So it will undergo oxidation and will give you a tertiary butyl alcohol. Addition of oxygen. This is the product that I am going to get on oxidation. Correct? So one thing you remember, alkane with tertiary hydrogen will undergo oxidation. So that is the option number C, will undergo oxidation by using what? KMnO4. So that was my question number 8. So let us go for next one, 9th one. Which of the following has maximum stability? So you learned this one in what? Previous chapter 2. So based on inductive effect, same is repeated over here. Let us ignore it, or else it's not belongs to what this chapter actually, but still we will discuss which of the following has maximum stability. They are asking. First one is methyl carbocation, second one is what? Primary carbocation, third one is C, secondary carbocation, and the fourth one is what? Tertiary carbocation. And we all know that tertiary carbocation is more stable. So that is why for 9th question, for 8 we got C. For 9th question, tertiary carbocation, that is nothing but my D. Option D is correct for question number 9. Question number 9, option D. Correct. So let us go for the next. The most volatile compound is the question, the 10th one, the most volatile. So why they are saying so? The most volatile compound is nothing but the one who is having low boiling point, you can say. Low boiling point. Right? Volatile in the sense, its boiling point will be below room temperature. If in room temperature it evaporates, it evaporates at around 25-27 degrees Celsius, means its boiling point is below that, below than what? Room temperature. That is nothing but my volatile. So they have given 4 options. Which of the following is volatile? They said one is 2,2-dimethyl propane. 2,2-dimethyl propane in the sense CS3, CS3, CS3. Correct? No? So this is 2,2-dimethyl propane. Option number 1. Second one is 2-methyl butane. Second one is what? 2-methyl butane. CS3, CS3, 2-methyl butane. Let us go for the third one. Third one is isobutane. Third one is what? Isobutane. Isobutane is nothing but 2-methyl propane. Isobutane. And the fourth one is what? N-pentane. N-pentane CS3, CH2, 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 CS3, 1, 2, 3, 4, 5. So N-pentane, 2-methyl butane, isobutane, 2,2-dimethyl propane. So they are asking which among these is a volatile compound. They are asking which is very unstable, highly unstable. We know that as branching increases, their stability goes on decrease. Correct? No? So that is why among these, option 1, 2,2-dimethyl, which has more branches, 2,2-dimethyl propane is less stable. And that is why its boiling point is below what? Room temperature. And that is why we can say that it's a volatile. It's a volatile compound. So for question number, how much? 10. 10th one. This is 10th one. Question number 10, option A is the correct answer. Option A is what? Correct answer. Clear? So let us go for the next one. 11th one. Let us talk about question number 11. In Wurtz reaction, the reagent used is, you know this, it's very simple. In fact, obviously the sodium metal in presence of what? Dry ether in fact. Sodium in dry ether. So that is nothing but my option number C. So for 11th one, it is option number C. Clear? Wurtz reaction. Sodium and dry ethers are used. Option number C. Let us go for the next question. That is nothing but my 12th one. 12th question. What they said? Which of the following reactions will not give propane? Which of the following reactions will not give propane? First one, they have taken propyl chloride or chloropropane, you can say, made to react with magnesium, and then followed by what? Hydrolysis, water. Then followed by what? Hydrolysis, or you can say water. Correct? So I'm talking about the 12th one. They are given CS3, CH2, CH2Cl. It is made to react with magnesium in ether, then followed by what? Water. So when it reacts with magnesium, we know that alkyl lights are going to give you what? Grignard reagent. That is nothing but my CH3, CH2, CH2, MgCl. Followed by water, they said. Obviously, when Grignard reagent is made to react with water, here I will write H2O. H2, water. It abstract what? Hydrogen. This MgCl will go along with OH. H2O is nothing but my H plus OH minus. H plus will get stuck to this one. So I'll be having CH3, CH2, CH3. See, CH3, CH2, CH2 minus Mg plus MgCl plus it will be. So this minus will be attacked by H plus so as to give your alkane, and I will be left with MgCl and OH. So Mg, OH and Cl. This is my byproduct. So by using first reaction, I am going to get propane. So they are asking which of the following reactions will not give propane? A is giving propane. Let us go for B. This is my A option. Option B is CH3COCl. CH3COCl. They have added CH3MgX, methyl magnesium Grignard reagent, followed by what? Hydrolysis. Followed by hydrolysis. When a carbonyl compound is made to react with Grignard reagent, please do remember we are going to get alcohols. We won't get alkanes. CH3MgX, in this case, this is minus, on Mg I will be having plus. So CH3 minus and MgX plus. So this CH3 minus will come and attack C, and there will be a transfer of electron. So I'm going to get CH3, C, double bond O will become single bond O minus, and I'll be having chlorine over here. So I'll be having this CH3 will come and attack. So at last, again I'm going to add one more mole. So it will come over here, chlorine will go out. At last, if you are writing all this entire mechanism, you won't understand. So just to remember, when carbonyl compounds are made to react with Grignard reagents, I'm going to get alcohol. I'm going to, sorry, ketone. Wait. I'm going to get what? Acetyl chloride forms ketones. In fact, they'll form what? Ketones. They'll form ketones, not alcohols. Ketone. So that is why, by using second option, by using second reaction, I won't get propane. My intention is to get what? Propane. But here I'm getting what? Ketone. So option B will not give you what? Propane. Remaining option C is propene. B2H6 they said. Correct? Hydroboration followed by acetic acid they have added. Obviously, it is going to give you a alkane. That is nothing but my propane. So option C will also give you a propane. Option D is alcohol. This alcohol on reduction, phosphorus in Hi, red phosphorus in Hi. It's a reducing agent. On reduction, alcohol also gives you what? Propane. I mean alkane. So option D also gives you propane. Option C also gives you propane. Option A is also giving you propane. But option B is giving you what? Ketone. Option B is giving you what? Ketone. So that is why this will not give propane. Hence, for question number 12, option B is the correct answer. Right? So this is very simple. How we are going to get ketone? See CH3. I was writing, but I stopped. See CH3. See O minus. I'll be having Cl. And now this CH3 came and attacked over here. So I'm going to get CH3. So these electrons will come back and chlorine will go out. So if it is going out, what I'll be left with, you tell me? CH3, C, double bond O. These electrons will come back. So double bond O. Cl went out. So this C is attached to CH3. So I'll be having what? CH3. I'm going to get ketone, not propane, by using B. So that's what the correct option is. B is the correct option. So let us go for the next one. That is nothing but my 13th one. Question number 13. In question number 13, let's see what they have done. The shape of methane molecule is very simple. The shape of methane molecule. You know some methane shape CH4. The shape of methane is carbon is undergoing sp3 hybridization. If it is undergoing sp3 hybridization, obviously the shape will be what? Tetrahedral. Clear? So that is why tetrahedral. Which option is correct? For 13, it is option number D. 13, it is option number D. Clear? So let us go for the next one. 14th one. 14. Which of the following shows only one brominated compound? Only one brominated compound. Means what they are asking is that which of the following compound shows only one brominated compound, means to which of the following compounds you can add only one bromine. Even if you are going to the other carbon, it should give you what? Same compound. That's what they are asking. Correct? Mono substituted, you can say. Which one of the following shows only one brominated compound? Let us go for option A. It is 2-butene. I'm talking about 14th one. Which of the following shows only one brominated compound? First one is butene. 2-butene they said. 2-butene is nothing but my CH3, CH2, CH double bond. Sorry. 2-butene they said. So CH double bond, CH, CH3. This is 2-butene. Correct? One brominated compound. It is going to give you one brominated. It will, let's see. If you are going to add bromine to this one, you can add bromine over here. You can add bromine over here. We'll get dibrominated also. They are saying only one brominated. One brominated. Correct? You can add over bromine over here, or over here, or over here. Correct? If you are adding bromine either over here or over here, it will be same. So one. If you are adding over here or over here, it will be same. So you are going to get how many bromo compounds? 2 bromo compounds. Correct? So which among the following will give you only one bromo? One brominated compound, only one bromine. Let us go for option B. This is option A. I'm going to get 2. You can add either to this carbon or to this carbon. Both are same. Bromine, if you are adding bromine. Correct? 2 bromobutane. You can add over here. That will be 1 bromobutane. Correct? If you are adding over here, again it is nothing but 2 bromobutane. If you are adding over here, again it is nothing but 1 bromobutane. So it is going to give you 2 brominated compounds. They are asking only 1 bromine. Let us go for B. B is 2,2-dimethylpropane. 2,2-dimethylpropane is nothing but my neopentane. You are supposed to add bromine. You can't add bromine to this carbon. There is no hydrogen. Correct. So now you can add over here. So this will become what? CH2Br. Let's imagine this is one of the compounds. Okay, one. So I can even add over here too. Is it different compound? No, it is same compound. You can even add bromine over here, CH2Br. It is same compound. You can even add Br over here. It is also same compound. So wherever you want, you can add 1 bromine. That is going to give you only what? 1 brominated compound. So neopentane will give you what? Only 1 brominated compound. But this guy can give you 2. So here you can stop. In second option, 2,2-dimethyl. In this case, 2,2-dimethylpropane, we can get only 1 brominated compound. So that is why for 14, option number B is the answer. By using 2,2-dimethylpropane or neopentane, we can get only 1 brominated compound. Or monobrominated, you can say 1 brominated compound. So that is why it is option number B, 14th one. So let's go for the next one, 15th. They said they have given butane. In case of 15, they have given one butane. CH3, CH2, CH2, CH3. Butane they have given. And they have added AlCl3. AlCl3, HBr, aluminum chloride and HBr. Product, you will get a product. Which product you are going to get? They are asking. They have given 4 options over there. Correct. So when you are adding AlCl3, it will undergo what? Isomerization. It will give you what? Isomerization. So this will be isomerized. This butane will become what? Isobutane. That is nothing but my CH3, CH3, CH, CH3. It will undergo what? Isomerization in presence of AlCl3. So that is right. Option number B is correct for what? 15. For 15, it will be option number B. Clear? So let us go for the next one. That is nothing but my 16th one. Let us move for the 16th one. So what they are asking in 16th case of what? 16th one. Let's go for 16th. Question number 16. Which of the following statement is not true for ethane? 16. Which of the statements is not true for ethane? Let us read one by one. It can be chlorinated with chlorine. Ethane can be chlorinated with chlorine by substitution reaction. We can say by what? Through what formation of what? Free radical mechanism. So it can be chlorinated with chlorine. Yes, it is possible. It is a true statement. They are asking which is not true for ethane. So let's see. Let's go for B. It can be catalytically hydrogenated. Ethane, hydrogenated. What do you mean by hydrogenation? Addition of hydrogen. See, for alkene or for alkyne, you can add hydrogen. But for alkane, hydrogenation is not possible. So ethane is a saturated compound. It cannot be catalytically hydrogenated. But option B, they are saying it can be catalytically hydrogenated. Ethene can be catalytically hydrogenated, but ethane cannot be hydrogenated, catalytically that hydrogenated. So option B is not true for ethane. Let's go for 3. When oxidized, produces CO2 and H2. Yes, alkanes on oxidation, strong oxidation or on combustion, you can say, they'll give you a carbon dioxide and water. That is also true. Correct. Option, it is a homology of isobutane. Ethane is a homology of what? Isobutane. It is differ by what? It's a homology. Correct. So that is also true. It is a homology of what? Isobutane. Which one? Ethane. correct? But it can be catalytically hydrogenated, they said, in P. So that is not possible. That is not true for what? Ethane. So for 16, option B is the correct answer. Option B is what? Correct answer. Clear? So let us go for 17. Which of the following has the highest boiling point? Which of the following has a highest boiling point? I'm talking about question number 17. So question number 17, A is neopentane, which has branches, neopentane. Option B is n-butane, n-butane. Option C is n-heptane, it is n-heptane. Option D is isobutane, isobutane. So they are asking which of the following has highest boiling point. See, branching increases, boiling point goes on decrease due to the decrease in what? Surface area. So among this, option C you can see it has heptane means what? How many? 7 carbons. Normal heptane, that 2 straight chain hydrocarbons. Straight chain hydrocarbons are more stronger or more stable compared to branched one. So as branching increases, boiling point goes on decrease. As number of carbon decreases, boiling point goes on decrease. As number of carbon increase, molecular mass increase, boiling point increase. So among this, n-heptane is very stable and has 7 carbon. So this should have highest boiling point among these 4. So for question number 17, option C is the correct answer for 17. Clear? So let us go for 18. Which gives methane when treated with water? They have given 4 options. Among that, they are asking which gives methane. I want methane as a product. Please do remember, I want methane as a product. I want methane as a product. Which among the following will give you methane when treated with water? So I got to know one more reactant. One of the reactant is water. Correct? So that's what they are asking. Which gives methane when treated with water? First one is silicon carbide. Second one is calcium carbide. Third one is aluminum carbide. Fourth one is iron carbide. Remember, calcium carbide, aluminum carbide, iron carbide, silicon. Among these, aluminum carbide when treated with water, it is going to give you methane. So that is nothing but my Al4C3. Aluminum carbide formula is what? Al4C3. Aluminum carbide. When it is treated with water, I am going to get what? Methane plus what? Al3O3. I will write methane plus Al2O3. So the product is methane plus Al2O3. Balance it. I got the 3 moles of methane and 2 moles of Al2O3. So aluminum carbide, when it is treated with water, it is going to give you what? Methane. This is the reaction. So for 18, option number C is correct. Option number C is correct. Correct? Similarly, calcium carbide will give you ethane. Like that, the different will give you different products. They are asking methane. Aluminum carbide on treatment with water will give you methane. This is the reaction. Alright. So let us go for the 19th one. Let us go for the 19th. Methane and ethane both can be obtained in a single step. Please remember, methane and ethane. Methane 1 carbon and ethane 2 carbon. Both can be obtained in a single step. From what? From what they are asking. So they have given methyl iodide. A is methyl iodide. B is ethyl iodide. C is methyl alcohol. D is ethyl alcohol. Among these 4, by using which of the following, I can get both methane and ethane. They are asking. Both ethane and what? Methane. Clear? Here. So here it has to be 6 moles of water. So this is now this is balanced. Now it is balanced. I'm talking about the question number 18. So let us go for the next one. So this was missing over here. That's why I have written. So it has to be 6 moles of water. So now it is balanced. Here, now it is balanced. Here, so let us talk about the 19. Methane and ethane both can be obtained in a single step. Question number 19. A, they have given methyl iodide. Let us see whether it is possible from A. Option A, methyl iodide. By using methyl iodide, is it possible? So let's see. So if suppose I'm having methyl iodide, CH3I, I can go for reduction. I can go for what? Reduction in presence of reducing agent. In presence of what? Reducing agent. So that I can get methane plus HI. Hydrogen iodide. So by using methyl iodide in a single step, I can prepare methane. Is it possible to prepare ethane too? Let's see. CH3I, I am having methyl iodide. Let us treat this one in presence of sodium with sodium in presence of diether. Means 2 moles of methyl iodide, 2 moles of sodium. What you are going to get, you tell me? CH3, that is nothing but my ethane. CH3. So I got ethane. So this ethane can be prepared by using what? Methyl iodide in a single step. Correct? No? So that's what they are asking. They are asking methane and ethane both can be obtained in a single step from what? Methyl iodide. It's possible. So option number A is the correct answer for what? Question number 19. Correct? Question number 19. So from using methyl iodide in a single step, we can prepare methane. We can even prepare what? Ethane. Methane by what? Reduction. Ethane by what? Wurtz reaction. By using Wurtz reaction, methyl iodide can be converted into ethane. This methyl iodide can be converted into methane by reduction. Clear? Let us go for the next question, the 20th. 20th. In alkanes, the bond angle is the bond angle. They are asking about what? Bond angle. In alkane, see, hybridization of carbon will be what? sp3. That means in alkanes, carbon hybridization will be sp3. If it is sp3, obviously it will be what? Tetrahedral. Shape of the molecule will be tetrahedral. If suppose it is a tetrahedral, in case of tetrahedral, the bond angle is 109.5 degree. Please do remember the standard bond angle. If suppose it is a sp3 hybridized carbon compound, the shape it will be tetrahedral, and if it is tetrahedral, the standard bond angle is what? 109.5 degree. So that is why option number A or 20th, option number A is correct. Option number A. Clear? So let's go for question number 21. Very simple. 21. Halogenation. I'm talking about 21. Halogenation of alkanes is an example of halogenation of alkane. You might have learned this one in SSLC too. Halogenation of alkane. Halogen. Can you give me an example for halogen? Chlorine. Chlorination of methane. You might have heard. Right? Chlorination of methane. Chlorination of methane in presence of sunlight. Chlorination of methane in presence of what? Sunlight. If you have in excess of chlorine, at last I am going to get what? CCl4. Well, that's what they are asking. Halogenation of alkanes is an example of what? Is an example in presence of sunlight. There will be a formation of what? Free radicals. So it's an example of what? Free radical substitution. It's a substitution reaction. In that, it is a free radical substitution reaction. There will be a formation of free radicals as an intermediate. The reaction intermediates in this case are what? Free radicals. Free radicals are formed, and lastly those free radicals will combine. So this mechanism follows 3 steps: chain initiation, chain propagation, and chain termination. Okay? So we don't have that mechanism, I think, for this syllabus. I think we don't have. Let it be. This is the question that we got in this discussion paper. So alkanes on halogenation. Alkanes can undergo halogenation. This can undergo halogenation. Is an example of what they are asking. It's an example for what? Free radical substitution reaction. So it is option number C. For 21, it is option number C. So let's go for the 22. Shall we go 22? In catalytic reduction of hydrocarbons, I'm talking about 22. In catalytic reduction of hydrocarbons, in catalytic reduction of hydrocarbons, which catalyst is mostly used or more preferred? More preferred, they are asking. So they have given platinum or nickel, they have given palladium, or they have given SiO2, silica, or else meshed metal. What do you mean by meshed metal? It's alloy of cerium, lanthanum, and other metals. It's an alloy. Meshed metal is what? Alloy, cerium, lanthanum, and other metals. Meshed metal. So which among these metal is used as a catalyst? More preferred catalyst. So here it is option number A. It is option A. Platinum or nickel are more preferred. Finely divided platinum or nickel is more preferred. So it doesn't mean that palladium cannot be. Palladium can also be, but more preferred is what? Platinum or nickel. So that is why it is option number A for 22 options. So platinum or nickel is used in catalytic reduction of what? Hydrocarbons. Okay. So let us go for the next one. That is nothing but my 23. 23rd. Which of the following does not give alkane? Which of the following does not give what? Alkane. Option A, reaction of methyl iodide with sodium. Wurtz reaction. By using Wurtz reaction, we can prepare what? Alkane. They are asking which will not give alkane. So option A will give. Leave that. Let's go for option B. Reaction of sodium acetate with soda lime. Soda lime is nothing but, what do you mean by soda lime? Soda lime is decarboxylating agent. Soda lime is a mixture of what? Sodium hydroxide and calcium oxide. Decarboxylating agent. So salts of carboxylic acid. Salts of carboxylic acids undergo decarboxylation in presence of soda lime so as to give you what? Alkanes. So alkanes can be prepared by second method too. So option B is also going to give you what? Alkane, but they are asking which will not give, which does not give. Let's go for the third C. Electrolysis of concentrated sodium acetate solution. Electrolysis is nothing but coal-based reaction. So by using that also I can prepare what? Alkane, but they are asking which is does not. Obviously 4 does not, because all these 3 are given. So let's talk about 4 too. So reaction of ethyl chloride with alcoholic QH. Reaction of what? Ethyl chloride with what? Alcoholic QH. Let's talk about the option D. I'm talking about question number 23. In that option D, they have an ethyl chloride. Ethyl chloride reaction with what? Alcoholic QH. Ethyl chloride is nothing but CH3, CH2, Cl. Ethyl chloride. Ethyl chloride is made to react in presence of what? Alcoholic QH. So this won't give you what? Alkane. Instead, this will give you alkene. Instead, this will give you what? Alkene. See, in alcoholic QH, OH minus acts as a base. It acts as what? Base. It abstracts proton. It abstracts proton from beta carbon. This is my beta carbon. This is my alpha carbon. So it attracts or it removes a proton. CH3 can be written in this form, CH2 and H. Clear? I'll write CH3 in this manner. So this will abstract this proton. This will abstract this proton. So then what happens? These electrons will come and form a double bond over here, and chlorine will leave the molecule. And chlorine will leave the molecule. So what I'll be left with? CH2, double bond, CH2. I won't get alkane. Option D is going to give you alkene. It won't give you what? Alkane. That's what they are asking. Which of the following does not give alkane? Fourth, D will not give. D will give alkene. It's an example for elimination reaction. It's an example for what? Elimination reaction. So what all I have removed? I have removed proton, hydrogen. I have removed chlorine, halogen, hydrogen, halogen. I have removed hydrogen, halogen. So dehydrohalogenation. Dehydrohalogenation. Correct now? Dehydrohalogenation. Dehydrohalogenating agent is alcoholic QH. Alcoholic QH is dehydrohalogenating agent. I have removed hydrogen and halogen. Addition of hydrogen halogen is hydrohalogenation. Removal of hydrogen halogen, dehydrohalogenation. Dehydrohalogenating reagent is alcoholic QH. You need this. Just remember. So let's go for the next question. That is nothing but my 24th. So let's see what they have given in 24th. 24. Which of the following compound has maximum boiling point? This is according to what? Again, same concept. We have already discussed these things. Let's go. I will directly give you what option. That is my option number A. Correct. 24 option A. N-hexane has a maximum boiling point, obviously because of straight chain and maximum number of carbon. You can go through those. 25 because 24 was a similar, which we have already discussed. 25. Which of the following has maximum boiling point? Again, the question is based on what boiling points, again stability. I have explained all those things. So they are asking which of the following has maximum boiling point, which is having a straight chain, is having maximum number of carbon. So that is nothing but option B. So for 25, I'm having question B. Option number B is what correct answer for 25. Let's go for 26. Aqueous solution of the following compound on electrolysis gives ethane. Aqueous solution of following compound on electrolysis gives ethane, nothing but coal-based electrolysis. In coal-based electrolysis, we are taking aqueous solution of sodium salts or potassium salts or carboxylic acids. Okay? Obviously, they are going to give you what alkanes. So they are asking which among this will give you what alkane. So let's see. Option A is acetic acid. No, we need salt. Option B, acetamide. No. Option C, potassium acetate. Potassium acetate is nothing but, I'm talking about 26, right? 26. Potassium acetate is nothing but CH3CO minus K plus. Potassium acetate. So this potassium acetate on electrolysis. This CO2 will go. I'll be taking 2 moles of this one in coal-based electrolysis. So this part will go. I will left with 2 free radicals of this two methyl free radicals. At the end, while writing mechanism, we'll get to know. While discussing preparation, they might have explained at last. You will be having what 2 methyl free radicals. Those 2 methyl free radicals will combine so as to give you what ethane. CH3, CH3 plus CO2, 2 CO2 plus 2 KOH plus H2. So by using potassium acetate, we can prepare what? Ethane. That's what they're asking. By using which of the following we can prepare ethane? Electrolysis gives ethane. Which of the following? So potassium acetate, that is nothing but the potassium salt of carboxylic acid on electrolysis gives you what? Ethane. So option C for 26, option C is the correct answer. Clear? So let's go for 27. Which of the following does not decolorize bromine solution in carbon disulfide? Please do remember, which of the following does not decolorize bromine solution in carbon disulfide? Means which of the following will not react? Decolorize in the sense which will not react. Please do remember, alkanes will not react with bromine water. Or alkanes won't decolorize bromine, whereas alkenes and alkynes. Also remember, saturated compounds, saturated hydrocarbons will not react with bromine water, will not decolorize bromine. So that's what, that is why ethane does not. Among this, I am having acetylene, I am having propane, I am having ethane, I am having propane. So option A, B and D are unsaturated compound, whereas my option C is saturated. Ethane is a saturated. So saturated compound does not decolorize bromine. So that is why for question number 27, so correct option is what? C. C is the correct option for question number 27. So let's go for 28. The preparation of ethane by electrolysis of aqueous solution of potassium acetate, same, based on coal-based electrolysis, correct, is called as simple. Option number C, coal-based. So 28 is also for coal-based. So the correct option is again for 28. It is what? C, coal-based synthesis or coal-based electrolysis, you can say. So let's go for 29. I'm talking about 29. Clear? As the number of carbon atoms in a chain, increases, the boiling point of alkanes Very simple. As number of carbon in a chain increase, molecular mass increase. Molecular mass increase, obviously boiling point has to increase. So it is option number A. For 29, very simple, theoretical, memory-based question. It's A. It increases as the number of carbon in a carbon chain increases. Boiling point obviously goes on increase because of increase in molecular mass. Okay. So let's go for the next. That is my 30th. So dry distillation of sodium propionate with soda lime gives sodium propanoate. They said. I'm talking about 30th. Sodium propanoate is nothing but there are 3 carbons, so that is nothing but CH3, CH2, CONA. This is my sodium propionate. Dry distillation of sodium propionate with soda lime. Soda lime is nothing but my anyway sodium hydroxide in presence of what? Calcium oxide. Presence of what? Calcium oxide is going to give you what? They are asking, but dry distillation of sodium propionate with soda lime gives what? What will be the product? Decarboxylation. This entire group will go out. Na2CO3. Na2CO3 will go out. Then what I will be left with? CH3, CH2, this H. CH3, CH3. So I will be having CH3, CH3. So dry distillation of this sodium propionate, with soda lime, which gives you what? Ethane. So option number C. For 30th, C is the correct answer. For 30th, C is the correct answer. Okay, so let's go for 31. What is the chief product obtained when the n-butane? So let's talk about the 31. What is the chief product obtained when n-butane is treated with bromine in presence of light? In presence of what? Light, they said. Means in presence of light. See, I'm having n-butane. N-butane is treated with bromine in presence of light. N-butane, and write n-butane. So I'm talking about 31. N-butane is CH3, CH2, CH2, CH3. This is treated with Br2, bromine, in presence of what? Light at 130 degrees Celsius. Hnu. Hnu is nothing but light. Right? At 130 degrees Celsius. What I'm going to get? Please do remember, bromine is to be added to what? Alkane. A substitution reaction. So there is a possibility of formation of 2 products. This bromine can go and replace hydrogen of this carbon, or also this carbon. This or this. If it is going to replace this, nothing but same. If it is going to replace this, nothing but same. So however, I am going to get only how many? 2 products. So one is 2-bromobutane, correct? No? One is 2-bromobutane. So that is nothing but my CH3, CH2, CHBr, CH3. One is 2-bromobutane. Another one is 1-bromobutane. That is nothing but my CH3, CH2, CH2, CH2Br. This is 1-bromobutane. Among this, this first compound is a major product. Second one is my minor product. Because here in this case, bromine is attached to secondary free radical. Here it is formed to a primary free radical. Among these two, which is stable. So this intermediate was stable. So the product which is formed through the formation of stable intermediate will become major product. A product which is formed through the formation of unstable intermediate is what? Minor. So it is formed through the unstable intermediate. This product is formed through what? Formation of unstable intermediate. Here in this case, this product is formed through the intermediate. Which intermediate? Stable intermediate. So that is it. This is my major. 2-bromobutane is major compared to 1-bromobutane. Secondary, primary. This is major. So that is why my option, which is the correct option, generally you need to give what? Major product. So option A for 31, it is option A. Option A is the major product. So let's go for 32. Let us go for 32. The tetrahedral nature of carbon was first given by, the tetrahedral nature of carbon is first given by Label and Bentoff. Option number B. It's very simple. Label and went out have given the tetrahedral nature of what carbon. Correct? So that is option B for 32. It is option B. So let's go for 33. 33. Formation of alkane by action of zinc on alkyl halide. Formation of alkane by action of zinc on alkyl halide is called. See, formation of alkane by action of sodium on alkyl halide is called Wurtz reaction. Then if there is a zinc, then it is option A. Frankland's reaction. Frankland's reaction. Option number A. If you are getting alkane alkyl halide using sodium, it is Wurtz. In this place of sodium, if you are using zinc, it will be Frankland's reaction. So question number 33, option is what? A. Frankland's reaction. Let's go for 34. Let's go for 34. Name the hydrocarbon that is liquid at STP. That is liquid at STP. Obviously, we know that up to 4 carbons it is physical properties, gaseous, and after that till 17 liquid, and then after solid. So name the hydrocarbon that is liquid. Option A is ethane, B is propane, C is n-butane, D is n-pentane. 5 carbon. A, B, C, 4 carbon. D, in D I am having 5 carbon. So A, B, C are gaseous, whereas D, n-pentane is liquid. So option for 34, option D is what? Correct. For 34, we are having option B as a correct. 35. Last. So let's go for 35th. 35th. Which one of the following compounds cannot be prepared by Wurtz reaction? So drawback, demerit of Wurtz reaction. By using Wurtz reaction, you might be knowing we can't prepare methane. We can't prepare methane because Wurtz reaction. In Wurtz reaction, we are going to prepare alkanes with the combination of 2 free radicals, 2 alkyl free radicals. If suppose there are 2 alkyl free radicals, the minimum number of carbons in product I am going to get is what? 2. So we can't prepare alkane with minimum number of what? 1 carbon. So methane cannot be prepared by using what? Wurtz reaction. So that is the demerit or drawback of what? Wurtz reaction you can say. So that is right. For question number 35, option A, methane cannot be prepared by what? Wurtz reaction. Correct? So that's it. We have solved these 35 questions, and remaining are very similar. They are related to one another. Some of the questions we had already gone through the reaction and mechanism or the concept. So remaining 35, we have questions based on boiling point, again based on Wurtz reaction, again based on substitution reaction. So you can go through those things. We have already posted the key answers too. Correct? So rest of the questions are these will be discussed in next class. Okay. Thank you.